started, then we'll give a quick intro on what security testing is in our sphere. In this case, static application security testing, and from there we can go into how our tools actually run some scans. So I think just to start off here, let me go ahead and share my screen. And cool. I'm just borrowing some slides from a talk I did a little while ago on this, but with like kind of a traditional application security approach, what you'll have here is you'll push up your code, your feature branch, and open a merge request, merge that code into master, kicks off a CI/CD pipeline, and it goes through the process. At some point in that stage, you're pushing your code up to like a QA environment, and you'll have your security team enter, and security teams will run the security scans, create issues, things like that. So in our case, we actually kind of take a different paradigm where we're focused primarily on running our security scans before it actually gets merged into the master branch here. So with a more modern approach, the idea here is that we can actually run our security scans at the feature branch stage instead. So from here, what we actually do is you push up your code into a feature branch. We spin up a review app on our end, and we can run our security scans within the context of that merge request itself. So with there's a number of different security scans. There's dynamic and application security, dependency scanning, different methods. And in this case, we're talking about static application security testing. So SAST is really just analyzing code for patterns, in both analyzing source code and bytecode to recognize common anti-patterns when you're writing your code. In this case, it's making sure that you're not allowing any SQL injections to occur, you're minimizing cross-site scripting, you're just making sure that you're handling permissions correctly and things of that nature. So as part of our security scanning, it's tied right into the CI pipelines. So what we're going to do is we'll just pull up the documentation here. Go to Google and GitLab static application security testing. And here's our docs. So as you noted, this is a GitLab Ultimate feature. So once you have that license enabled on a given group, then you can kick off security testing on any of your products. The way that we really structure this is that you enable security testing for your CI configuration, and that actually works for all of your CI there. During the security scanning process, it looks for certain markers in your project for what language or what relevant scanner to use. And in some cases, if you're running Java, you might be running Maven, you might be running Ant, you might be using a different build system entirely. And we use a thing called an orchestrator to figure out what language you're running and run the necessary scanner accordingly. So in our case, Apex, we're going to be looking for what we consider to be markers in the language to determine that's an Apex project. Sometimes that's a package XML file, sometimes that's the SFDC project JSON file, things of that nature. So here's a little widget that you'll actually see in our merge request shortly. In this case, we're merging awesome feature into master. The pipeline is passed, and our SAST noticed that there was one security vulnerability, and that was fixed, and then 3 that were introduced in this merge request, as you can see from the little markers here. We also assign with each one a severity rating. That's this medium here. And it can range from critical to low. And it tells you exactly to the line where in your code that vulnerability is. So here's our severity levels. And as you can see, we cover a variety of languages, and right here is Apex. Our approach to security scanning is that we want to really stand on the shoulders of giants. So the idea is that we take a popular and a well-established tool in the community, in this case, PMD, and we build our wrapper around PMD and use PMD's existing security scanning capabilities. If we go ahead and just look at PMD real quick, we can actually see the Apex specific code metrics and Apex rules. In this case, these are the current security scans supported, and as soon as more work in PMD continues to improve, we can pull this directly into GitLab itself and scan for even more security issues. So right now we can look for things like CRED violations, CSRF attacks, from a lack of escaping cross-site scripting possibilities, and even there's an idea of suggesting using named credentials. In this case, we're recognizing a specific paradigm that's preferred in Apex itself to properly wrap credentials and pass those appropriately. Cool. So before we actually go into a demo of how exactly that works, do you have any questions or
thoughts? I did, and I think you answered it with PMD. So I was wondering, how do we determine if something is low, medium, or critical vulnerability? Is it PMD kind of suggesting or bubbling up that severity level?
Yeah. So in this case, it's PMD, and as you can see, there's a priority level here. We spend a lot of time thinking about this paradigm on like what we consider to be a vulnerability. And we are working on a new issue right now on first-class vulnerabilities, which is the idea that a more appropriate term for this thing that we find in a pipeline here, this is a finding. And a finding is the potential for a problem. So before you actually merge code in, it's not necessarily a vulnerability. It's in this kind of pre-merge state, right? So we can't really say your code is vulnerable until you merge that in. And once it is, then it could still be a false positive, but I would say there's a much higher probability of vulnerability once it's actually in your deployed branch. So there's an idea of priority that comes from some of the underlying tools. In some cases, it's a mixture of severity and confidence. But we use a number of these different measures to essentially assess the risk of each one and adjust accordingly.
Got it. That definitely makes sense. The other question I had was the green check mark in the summary
Yes.
above, and you had mentioned this had been fixed or addressed. Is that part of like automatically being remediated by GitLab, or was this in a previous run? Someone had already fixed it, but it still came up as within the history of the system.
That's a great question. And in this case, what happens is the developer who opened Awesome Feature Branch fixed it themselves. We do have auto remediation capabilities within GitLab. Currently, that's limited to dependency scanning and only certain package managers. But even with our auto remediation feature, part of our security paradigm is that we enable developers, and we are essentially non-blocking and augmenting abilities. And in that case, what our auto remediation does is it will create a merge request back into this branch to fix the problem. It doesn't auto merge it. It doesn't auto bump it. It provides the details and information to the developers to handle this themselves.
Got it.
And I don't think that we'll be able to quite dig into the auto remediation for now, but I guess, as I said, currently it's based on dependency scanning. So hopefully we'll get that over to static analysis soon.
Got it.
Cool. Okay. So let's see. I think another thing to point out here is, as I mentioned, there's a number of supported languages here, and we have different tools. PMD in particular does analysis of quite a bit of different Java code. But for our Java project specifically, we use a tool called Spot Bugs as well. Now, Spot Bugs, part of the appeal of that is that we can actually, in some cases, we can analyze the bytecode itself and traverse the AST to figure out exactly how something is, the context by which something is being called, to figure out exactly how vulnerable it is. And that can inform our confidence or severity levels. Say if there's a hot code path that gets called 1 million times versus twice a year. But it really depends. In many cases, we have our many different tools running both source code analysis and bytecode analysis. Okay. So so let's get into how to actually enable this. Now, with much of in all of our security scans, the process is adding this to your pipeline configuration. So we go to our configuration section here. We support SAST in GitLab 11.9 or later. And in the case of Apex, it's 12.1. So by running GitLab 12.1, then this should run automatically just by including the snippet here. So this uses our CI syntax to include a template called SAST. And this ships with every GitLab version, so it'll just pull that locally from within the installation and run it right there. Part of this template, what it does is it will, as I mentioned before, it looks for project markers. In the case of the Apex scanner, we look for an SFDC project JSON file, which is for newer Salesforce projects, or we fall back to a package XML file for some of the older ones.
Mhm. So we do have a CI template made for development for Salesforce, and we also have a project template made that includes a boilerplate for the SFDX project JSON.
Awesome.
So I'm wondering, when you add this include template, did that append the existing GitLab-ci.yml, or does that replace some of that functionality? How do you use this call if you already have a CI template for your project?
Yeah, in this case, you can just add this to the end of the file. The include will actually go ahead and append this on to any previous includes, so it won't override any, and it will just work with it. There's another way as well, which is within the context of a project, you can use the CI template. So you can click the drop down and select SAST to inject it indirectly. But in that case, that will actually override the content because you're essentially templating on a new one. So in this case, your best bet is to, as it says here, you essentially just copy paste that in, and we can demo that in just a second.
Got it.
Cool. So I think that I pulled up this project right here. It was one of the more popular Apex projects I found on GitHub here, and we'll go ahead and use this one as our security scan base project. So let's go to gitlab.com. And then we're going to go ahead and import a new project. And go ahead and let it take its time here. There we go. Okay, so we're going to import a project by URL. Go ahead and paste in this URL. And I'm going to call my project Apex Test Project. Just go ahead and use the same project slug. And we're just going to make it public. Okay, so we've now imported our project. As you can see, this is 100% Apex. And it doesn't have a CI configuration yet. So what we're going to do is we're going to set up CI/CD here. And when I click this, it's essentially the equivalent of creating a new file in this directory and then specifying it as our CI configuration. So go ahead and click that. And then we'll go ahead and go back here to the docs. Go ahead and copy this and paste it in. And then I'm going to say enable SAST. And we'll create a new merge request. So what we're doing in this case is we're adding a new CI configuration. As soon as I commit these changes, it's going to recognize new changes on a new branch and start running a pipeline. Now, in this process, it will actually run our security scan, since this is the only job defined in our pipeline currently. Now, one thing to note here is that when this actually runs, this is going to actually be running against our main branch. Normally, when you run code on a merge request, it will only look at those changes within the merge request, and it will diff them against changes in your master. But in this case, there's not really anything to diff because no security scan has been run on the master. So it's going to recognize changes in the master branch within the merge request. And this way, it just really helps you get started to recognize with your first scan exactly what's vulnerable. And then from there on out, it will just give you context for your own changes.
And that's where we will get the green check mark because we may have remediated or fixed it before, and then subsequent testers will know that historically you had that vulnerability or you had that violation and it was remediated. Therefore, you get the green check, right?
Actually, in this case, the green check is only there to clarify if something has been fixed specifically.
Okay.
If it's not present, if there is a vulnerability in your master branch and you don't touch that file or that code at all within the merge request, it won't be present. And so we actually aim for two major stakeholders with our security tools. There's a developer and then there's a security professional. So as such, there's really two different contexts by which we expose vulnerabilities. As I'm explaining this, we have this pipeline here. It's pending. It'll get picked up by a runner in a second, and we'll go ahead and check it. Just click through to check out the results here.
Okay.
But we have this over here. We have a thing called the security dashboard. Security dashboard is an overview of all vulnerabilities in your code base. So when you go here, it will show every vulnerability that is currently in your default branch. So that is the context by which you have an overview. Within the context of a merge request, though, the aim is to target developers. And developers, they might not care if there's a vulnerability that's been introduced in some other merge request. We only give them the context of the changes they have made then. Does that make sense?
Yeah, it does.
Awesome.
I presume you're using the shared runners, waiting for
Yes.
one to get picked up. Yeah. It's like morning rush hour.
Yeah. So we'll just give this a minute while it's working, and let's go back to our merge request while it's running. So right now, there's no security widget here because our security scans have not been run yet. But right in here, we'll see our widget soon, the same one you see here in the docs with slightly different data that will tell us exactly how many vulnerabilities are present in our master branch. Now, along with this, we have an additional feature that we've just recently released called a security approvals. So if you create a specific security group, that will actually be an approval group right here, then you can enable a mandatory approval if there is a vulnerability of medium or higher confidence. So the idea here is that if you enable a security approval group, then they will be required to approve something if a specific vulnerability of a specific severity is detected. So that's a really cool addition to our scans as well.
Nice.
Okay, so our job's running here. Let's go ahead and check it out. Now, the first thing we're going to see here is our security scan. It kicks off, it pulls down our SAST container, and as it runs, you can see it actually starts running our orchestrator and trying to figure out what kind of project we've got. So our Go scanner looks for some Go code, our Spotbug scanner looks for some Java code, Flaw Finder for .NET, and we go through and ensure that each project where this is compatible, it runs our scan. Additionally, our secret detection kicks off here, and in this case, it determined that the project is compatible with secret detection. In this case, just ensuring there's no API keys or any high entropy strings that are present. Looks like that got pulled down, it ran successfully, and then right there, our PMD analyzer ran and recognized Apex code. From there, it pulls down the PMD analyzer and starts running that as well.
Looks like we've picked up a few.
All right, yeah, so not to get overly excited that there's security vulnerabilities, but here we go. So it looks like in our summary, there was 5 vulnerabilities detected, all by PMD Apex. So while the secret detection ran, it didn't find any secrets. And within these files, at these specific locations, we're seeing CRUD violations, and then a cross-site scripting from URL param, which is likely an unsafe URL param is getting passed straight into some function call. So the artifact ran, and this is one very important part. While there are security scans detected, we still consider the job to be a success. In this case, our goal is to provide developers with more information. So you shouldn't expect a pipeline failure when there's security scans. This is just information that we're providing to developers to make a decision within the merge request. So let's go ahead and go back to the merge request. And our security scan detected 5 vulnerabilities. This part right here is what I was talking about. It essentially recognizes that There are 5 vulnerabilities, but these are from the source branch as well. So these are not just within the context of the merge request. From here, we can expand it out. And these are the vulnerability types, and these are the locations. Let's go ahead and open this one up.
Mm-hmm.
Rule validates that you're checking for access permissions before running a SQL operation. And then here's a file. And if I click through here, we go to the exact area where this is occurring within the context of this branch. And I can figure out, oh, that's not a big deal. And then I can go back and I could dismiss this vulnerability. I can leave a note during dismissing it. Not a big deal. And then that one's gone. Let's take a look at one more here. Make sure that all values are properly escaped. Take a look at the context. In this case, it looks like we're passing this node straight into a query. Where's our node here? Get params, get node. So it looks like it's just pulling a string straight from a parameter and passing it right into the query. That's a bit concerning, so I'm going to go back to my merge request here. I'm going to create an issue to fix this. In this case, I can follow a standard development flow. I can assign out the issue. Someone can make a merge request straight into this target branch, and we can actually remediate this before it even gets merged.
Yep.
So I'll create that issue, and we can follow up.
So I noticed there it says create confidential merge request, and that'll basically kick off the development cycle where someone can actually make the commit against that confidential merge request and then kick off the pipeline all over again.
Yep, that's right. So we can go ahead and just do this. Now, depending on the context of your project, if your project is public, you may want to do everything confidentially there. Mm-hmm. If it's a private projects and confidential issues or MRs, it just really depends on your organization if it's a good fit.
Yep.
And then here's our issue right here. As you can see, if we look at this previous one, we can undo the dismissal, see who dismissed it and why, or we can create an issue to fix it as well.
Brilliant.
Cool. And that's our security scanning using Apex.
Really cool stuff. So there's 2 things that I wanted to walk through with you if you have the time. One
Absolutely.
is, where do we assign those security groups for approval?
So if we go into our general settings here, we can go to merge request approvals, and we can create approval groups here. Approval groups is a really powerful feature. So there's quite a bit here that you can use. You can do things like require approval from code owners. So if you define a code owner file, say, I am a docs person, so any file in the doc folder I want to be an approver for. You can do things like prevent approvals by merge request authors, or maybe I have a mental process by which I push up code and I review my own code separately. So this may or may not be applicable, etc. So what we do is we end up creating an approval rule. In this case, we're going to call it vulnerability check. One approval, and actually, you need to be a member of this project, so I'll just use myself here. And add approval rule. So you can see this right here. Vulnerability check requires one or more merge request approvals only if high or critical security vulnerabilities are detected. So in this case, we've defined this here. We go back to our merge request. I'll just do this. In this case, there's no approval required because I created the approval rule after the merge request has been opened. But let's go ahead and close this out. This code's still live on a branch, so let's go ahead and create a new merge request. I'm going to label this work in progress for now. Okay. And now no approvals are required because with our security check default behavior, none of these are high or critical, but there are eligible approvals. And so you see this pending approvals on the vulnerability check group is now optional. If I were to introduce a high one here, then this would actually become required.
Got it. That is really cool.
Yeah.
The next thing that I wanted to show you is if you would navigate to the following URL, gitlab.com/sfdx.
Got it?
And then there, yep, that's it. Cool. And so this is the group that we have where we keep our project template and our CI/CD template. So Francis helped us tremendously in creating that CI/CD template. And the project template actually includes the template from the second project below. So I was wondering, how would we inject the SAST scanning into this GitLab-ci.yml?
Yeah, so here's our CI configuration right here. As you can see, it's using the same include syntax, in this case, including a project and a file. Yep. So I can go ahead and just do this right here. And I need to fork it first because I don't have permissions. So let me just showcase this right here. We'll just go ahead and fork it. And we'll go right back to the docs here. And configuration. Then all we have to do is include this template right here.
Right. So and that will append it to the other template.
Yep. Just like that. And now we're including two templates. We're including this file template from this project and then our SAST template.
So where do we define when that job runs?
So in this case, the template job pulls in this case, template's really just pulling in some other YAML file, right? In this case, our file is called SAST, or our job definition within the template is called SAST. So within SAST, we can also override a couple things. In one case, let's say I don't want secret detection to run. And while it didn't pick up anything, we saw within the context of the purge request, secret detection was running. So if we go back to our docs here, you can see that there's quite a few configuration options. And this is all controlled via some variables. So we're going to look here at our SAST default analyzers. We're going to override the names of the default analyzer images. Or in this case, we only want PMD Apex to run. We don't want our secrets to run. So what we're going to do is we're going to say, we're going to define a new variable section. And we're going to have SAST default analyzers set to PMD Apex. Now in this case, we're overriding the variables defined in the template to only run our PMD Apex scanner. And we could even say only run this on, let me have to check my syntax on this, but we'll say refs master. In this case, SAST would only run on the master branch.
Got it.
Or you could say only branches, only run on branches.
Got it. So it'll only run on a feature branch.
Yep, that's it.
Any feature branch, just anything that's not master functionally.
Yes, let's go ahead and look at this because I'm curious. I'm trying to remember how this exact syntax, since I'm a bit rusty on the onlys. So for our only syntax, only defines the names of branches and tags for which the job will run, and except for when they will not run. Look at some examples here. Only on tags trigger schedules. Okay, so I think we'd use something a lot like this here. So I'll go ahead and copy that. We'll say it will be only branches except master. Because master really is just another branch. It's just, in our case, a specialty branch.
Got it. That is very helpful. So I presume I'll work with Francis and kind of share with him. If you could just submit this MR so he can review it as well. This might be very helpful for incorporating into the master CI template for Apex. development?
Yeah.
Awesome. Because I know he has multiple stages and some advanced logic in the imported template that's created in the same group. So I'm wondering where he wants to run it. I'll leave that up to him.
Yeah, sounds good. And in this case too, if it's a Salesforce project that doesn't have any Apex code, we're still going to be running our secret detection. We'll be running scans for Java code, anything else too.
Yeah.
And I just mark this work in progress for now until we review it more in our flow.
Brilliant.
Cool. Delete source branch, and we can squash the commits there. And we'll allow some commits. Let's review our changes. We're including just our template SAST and submit this merge request. Hey, it's my first one of the project. All right.
All right. Well, that was pretty straightforward.
Might need to assign this to. Oh yeah. Okay. So I can't assign this until because it's not my project, but
I can do that on my end.
Awesome. Okay. Cool.
Cool. So again, thank you so much for walking us through how to enable SAST for Apex and Salesforce development. I think this is extremely helpful, and I'm sure our viewers are going to find that useful as well. So I'm going to go ahead and stop the recording. Again, Lucas, thank you so much for having this Q&A discussion.
Absolutely.
Go ahead and stop the recording now.